In this video, we will be studying about uh, techniques of probability sampling and non-probability sampling. So first, we will have a look at what is probability sampling. So probability sampling is a purely an unbiased random selection. Here, we will not know which object or which individual will get selected as a sample, so that each one has an equal chance of getting picked. Probability sampling is a technique where every member of a population has a known non-zero chance of being selected. So everyone will have a chance of getting selected. So basically, we use it because it eliminates selection bias. So there will be no bias in the selection process. So it will be a proper representation of the population. It allows for mathematical generalization to the whole population. So this method helps us, or if at all we use probability sampling method, then we can automate the selection process or the sampling process by generalizing or creating some mathematical model for selecting of samples, like generation of random numbers, or some method can be used for selecting the samples. It provides high reliability for statistical inference because it is unbiased. So the results that we get or the inference that we derive from the statistical technique or testing will be more reliable because no bias will be present in the samples that we pick. So some of the techniques that we use for probability sampling are: first one, simple random sampling. This simple random sampling is also like we abbreviate it as SRS, simple random sampling. So here every individual has an equal probability of selection, often implemented via random number generators or drawing from a hat. See, basically it is like a lottery method, right? Uh, you have a set of elements or members in the population randomly by using either random number generator or by putting all these numbers into one hat and or in a bag, and like then without looking picking like a lottery. So like that, if at all we select the samples, then it is simple random sampling. When is it suitable, or when should we use simple random sampling? It is ideal for small homogeneous populations where a complete sampling frame or list of all members is readily available. If at all we have a sampling frame, that is a list of all the members in the population available with us, then, and if it is very small number, mm, or it is not very huge number of elements in the population, then we can go with simple random sampling technique. Second one is systematic sampling. See here, the selection happens at intervals. See, if you have a look at this particular diagram, the third element is picked as a sample, then sixth element is picked as a sample, then ninth element is picked as a sample. At equal intervals of 3, 6, 9, if at all I had furthermore, then 12 would have been picked as a sample. So here, every nth individual will be picked as a sample. Researchers choose a random starting point and then select every nth individual element from a list. as sample. So here the first one to be started was 3. Instead, you could start from 2 and the difference was 3, then you would get 2 as a sample, 5 as a sample, 8 as a sample. So here picking up the first element is randomly done. From there, every nth element is systematically being picked. So therefore, we call it systematic sampling. This method is more efficient than SRS, simple random sampling, for large lists, but requires that the population order has no hidden uh, patterns. So here, basically it is suitable for large populations. So I need not have the entire list available with me readily. So I randomly pick some particular first seed element. From there, maybe every third element or every fifth element or maybe every 10th element is picked systematically. But we need to make sure that in the arrangement in the population, I don't have any hidden patterns, right? So in that case, this method of sampling is called systematic sampling. After that, we have something called stratified sampling. So the word stratified sampling comes from a word strata. Strata means a set or a group. Fine. So stratified sampling is like uh, the population is divided into meaningful layers or strata based on either age or gender or income, and then samples are drawn randomly from each. So let us just have a look here, look at the diagram. If at all this was the population, I first created separate groups or separate sets or separate strata based on some logic, maybe based on the age group or maybe based on the income levels that they have. I have created multiple groups. Now from each group, randomly I select some number of samples. Then this method is called stratified sampling because the original population is divided into strata. The benefit or the advantage of using stratified sampling is it ensures that minority groups are adequately represented in the final results, reducing sampling error. Let me say I had some color, let me say yellow here. There were only two yellow figures here. Then, if at all I had gone with either simple random sampling or maybe I had have gone with systematic sampling, there was always a chance that these two yellow images would be skipped. That means to say there will be no representation of yellow at all in the sample. But in stratified sampling, what happens? Yellow also would form a group here. From that group also, I would have to pick one or two samples. So that means to say, from every strata, there will be a representation. That is considered to be one of the biggest advantages of stratified sampling technique. Modification of stratified sampling is your cluster sampling. Cluster sampling is instead of individuals, researchers divide the population into natural clusters like schools or cities and randomly select entire cluster to study. Let me say I'm supposed to perform a study on all degree colleges across Karnataka. Then every college, right? Every college will become a separate cluster. I am not randomly picking a few students from the college, that entire college will be treated as one cluster. And whenever I am supposed to randomly select, randomly I will pick maybe government first aid college, KGF, then maybe some government first aid college somewhere in Belgaum, or one more government first aid college somewhere in Chamarajnagar, somewhere. One full set, one full set is being picked. I am not picking individual elements from a cluster. The entire cluster, one single cluster, will become my entire sample. So that is the difference between stratified sampling and cluster sampling. This is highly cost effective for large scale studies where it is impossible to visit every location. So normally we prefer this type of sampling whenever the population is very huge and it is geographically distributed across large area, right? So in such cases, we prefer usage of cluster sampling. Then coming to non-probability sampling. Here, uh, we are not giving enough chances to every individual member to get picked. We are being judgmental, or we are being uh, very specific about the criteria based on which I am picking the elements. So it is called non-probability sampling. Non-probability sampling is a method of selecting participants for a study where not everyone in the target population has an equal or known chance of being chosen. So instead of relying on random selection, non-probability sampling relies on researcher's judgment, his convenience or her convenience, or a specific criteria based on which I individually pick the elements. So here it is not random picking. Because it does not use randomization, it is much faster and cheaper, but it also means the sample might not perfectly represent the whole population, because I'm being very choosy and I'm picking only certain elements as input or sample. So it may not be a proper representation of the population, right? So if at all I randomly pick some elements, then maybe most of the properties of the population will be found even in the sample. But when I'm being judgmental, let me say I am supposed to pick students from a class as representative. If at all I am choosing only intelligent students, then my sample is having only intelligent students. But in the college, if at all you have a look, not every student will be intelligent. There will be some dull students, there will be some lazy students. So that representation is not at all present in the sample. So that way, the sample that we pick may not be a proper representative of the population. So some of the techniques that we use in non-random or non-probability sampling are: first one is called convenience sampling, easy to access, or picking people who are closest or easiest to reach. Or let me say I am supposed to pick and study about students who are studying degree. So what I do is I do not go to some other college and I pick the students. Conveniently, the students who are available to me, whom I can reach very easily, I'll pick only those students. So here convenience is being used, or the ease of access or ease of selection becomes the criteria in sampling. So therefore it is not randomization, but it is convenience sampling. So we'll take one example here: standing in a shopping mall and asking passers-by for their opinion. So here I am not considering the entire public of the city. I am standing near the mall, and those who are coming to the mall, only the visitors to the mall will get or will have an opportunity to get selected as a sample. Others who are maybe traveling in the road or going to another mall, they have no chance of being picked as a sample. So therefore, randomization is not there, but my convenience is being picked. I'm not going to every mall and I'm not picking samples. I'm standing at one mall, whoever comes there, I'll pick them as sample. So the advantages, it is fast and cheap, but the disadvantages, it is highly biased. It might not represent the whole city or the entire population. The population may not be a proper, like the sample might not be a proper representation of the entire population. Then coming to the second technique that is employed for non-probability sampling, it is called purposive sampling, or it is also called judgmental sampling. So here an expert choice is being made. So I am picking and choosing who or which object or which member or which individual has to become a part of my sample. So the researcher uses his own knowledge to pick the best participants who fit the study, whoever is suitable or whoever will give me answers or whoever will give me answer which I am expecting. Based on that, if at all I select, I hand pick certain samples, then that method is called judgmental sampling or purposive sampling. Example, if you want to study expert gardeners, you specifically go to an award-winning garden club and pick the members. So here, every person who does gardening is not getting a equal chance or not getting a chance to be picked. Those who are only the members of the expert garden club or award-winning garden club, they will become the possible members for sampling. It is used when you need a specific type of person rather than random one. Let me say, I was giving you an example. If the principal wants to know about my teaching, and if at all I want to show that I'm a good teacher, then what I will do is randomly, I will not pick the students in the class. I will pick only the intelligent students or the students who will answer very nicely. I will pick only those students and I'll take them to the principal so that if principal asks questions, they will be able to answer and principal will feel that I am a good teacher, right? So this method of sampling, if at all I use, then it is called purposive or judgmental sampling. Then we have something called as quota sampling. Here, setting the targets is important. The researcher ensures that the sample has the same proportions as the population for certain traits. Let me say, in the entire college, we see that we have 80% girls and 20% boys. Then when I'm picking sample also, the same proportion has to be maintained. So I will be like picking 80% of my sample as girls and 20% of my sample as boys. That is, if at all I want to select 10 students, then I will pick 8 girls and 2 boys. So here I am being judgmental about the proportions, and while picking the uh, boys or girls also, I am being choosy. I am picking them for with convenience. Whoever is suitable, I am picking only those. So, first of all, assigning a quota is uh, not probabilistic in nature. Then, Within the quota also, when I'm picking individual elements, I'm using convenience. So there also probability factor is overlooked. Therefore, your quota sampling is considered to be non-probabilistic sampling technique. Then we have another called snowball sampling. Here, chain referrals are used. I will tell you what exactly chain referrals means. So participants are asked to refer others they know who meet the criteria. Let me say, I don't know many people, maybe in Jain College or in FGC or in any other college, whom I am supposed to pick as samples. So what I'll do is I'll catch hold of one student from my college. I will consider that person as sample. Then I will ask him or her if at all he has any friends in Jain College. So he will refer one student in Jain College. So I will pick that person as sample. So I'll ask that person in Jain College to refer me some student in FGC. So this way, from one sample, I am getting reference to the next sample. So this is called chain referencing. So if at all I use chain referencing, then that method of sampling is called snowball sampling. This is used for hard to reach groups like homeless people or secret clubs or rare disease patients. So where we will not get the exact data about the entire population. Under such situations, we prefer using snowball sampling. In snowball sampling, we have different methods of snowball sampling. One is chain referral sampling. The other one is respondent driven sampling. Then we have network sampling. Then we have seeded snowball sampling, where whatever might be the name. Here, the common thing is from one sample, I will get the link to another sample. So how exactly we are getting the link is up to the type of sampling that we are using. Hope you people have understood. So when we talk about the steps involved in sampling process, uh, see, first of all, we need to understand why sampling is important. For any research, for any study to achieve success in any research, success in research is built on a logical, unbiased, and disciplined sampling execution. If at all my sampling is very unbiased and it is done in a very proper way, if the samples are properly being picked, then the study will be more accurate and my predictions that I make will be more accurate and efficient when compared to if the sampling is not that good. So we will have a look at the steps involved in sampling. Steps in the sampling process. Step 1, define target population. That is, specify the entire group of people or objects that you want to draw conclusions about. If at all I want to study about students, then I'll have to decide whether I am supposed to study students of Karnataka or students of India or students across the world. So I'll have to decide what will be my population, right? So that will be the first step. Second step is identify sampling frame. Develop a comprehensive list of all members within the defined target population. So I'll first try to get the list of all members available in the population. That will act as my sampling frame. Then step 3 is choosing sampling method. So I am supposed to decide on either any of the probability or non-probability methods of sampling. So determine whether to use probability, that is random sampling, or non-probability, that is subjective sampling technique. Then once you have decided how you will be picking the sample, step 4 is determine sample size. I will have to decide how many samples I need to pick. So calculate the number of units needed to achieve statistical reliability and precision. How many samples I need, I'll have to decide. Then coming to the last step, which is step number 5, execute and collect data. So now implement the selection process and gather data from the final chosen sample units. So I'll have to now pick the samples and from them I need to collect the data. So this is the steps involved in sampling process. So in the next video, we will be discussing about sampling distributions. Thank you.